Welcome everyone. I guess we will start hearing the beep beep sound as the webinar progresses because it's 10, so time to start. So today we will be having this webinar called Projects Promoting Heat Pump Excellence. That basically it's a webinar to present the most outstanding heat pump projects that won the Heat Pump Award edition of 2021. So we have an agenda full of presentations. It will start with me. I will give a brief introduction about what the Heat Pump Award is for those who might be interested and like some news. Then we will have our sponsors, Brasco, will have their keynote speech given by Livio Calabrese, and then we will have the four presentations of four of the award-winning projects of the 2021 edition, and then we will have a brief Q&A. So if you have questions, you can ask them. What I would say is if you have those questions, you can use the chat and write them there. I would suggest that you indicate the name of the person you want to refer to so as to make it easier, like if then we address it on the Q&A or if the person can answer directly on the chat. So now, without further ado, I'm going to start talking about what the Heat Pump Award is. So the Heat Pump Award is a project by EHPA that basically aims at recognizing the most outstanding heat pump projects at a local level. It started back in 2011 and it had the name Heat Pump City of the Year Award. And that's it because initially it aimed to highlight those cities and regions that had put in place an energy efficient project using heat pumps. For last year's edition, for the first time, we created a brochure with the stories of the winners, like the winners that, by the way, we'll present now in a bit. So I recommend you to check that out. Not now, first listen to the presentations, but I think there's like very nice information there that you might be interested in. Then the Heat Pump Award, it's something that happens every year. We actually had just finished the 2022 edition. Back on the 28th of September, we had the award ceremony. So stay tuned for like hearing more about the winners in the next months. However, we will open the applications for the 2023 edition very soon. So stay tuned. You can actually click on the link or scan the QR code and it will guide you to the Heat Pump Award website. So you can check like anything that will happen in the next months. So yeah, now I think it's time to introduce our first speaker. So Livio is graduated in mechanical engineer from the University of Padua, and he started his career as a mechanical designer in Italy. But then he also worked in China and helped develop the domestic compressor market in the heating and cooling sector. He returned to Italy and he got his MBA program in the Bocconi School of Management, like a very important and prestigious university in Italy. And he specialized in business development. In 2017, he joined Frasco. Since 2018, he has been the group's sales director. And since 2019, he joined the board of directors there. So Livio, whenever you want, you can take control of the screen and you can start your presentation.
Good morning. Can you hear me?
Yes, we can.
All right. Then good morning and welcome everybody. The presentation should be already there. Let me see. Okay. All right. Then welcome and good morning everybody again. Today my personal target is to let you all know that heat pump is a viable option for clean heating in several applications and ranges, and therefore this ambitious title, Clean Heating is Possible today. The agenda for today is a quick introduction on who is Frasco and what to do to face the current HFC challenges we are facing today, because the way we are facing these challenges and their solution can be addressed as well on the heating industry as well. in order to reach our common target, which is to decarbonize the heating. By doing this, I will share you some meaningful case studies, not for promoting a target, but just for sharing knowledge and expertise and to increase the awareness on heating technology, on clean heating technologies. Then I will draw some conclusions that I hope will be of some inspiration, at least for some of you. Um, yeah, Frascold is a company which has been designing, producing, and selling reciprocating and screw compressors for HVAC sector since 1936, and nowadays is operating through its branches all over the world. We currently have branches in China, India, US, and we therefore cover all 86 countries. I believe it's worth today to share our mission, which is supporting our customers during the development journey, providing refrigeration and air conditioning solution for specific cooling and heating challenges. Because I believe today we are in front of a huge challenge, which is decarbonizing heating. We are on the right direction. It's just a matter of increasing awareness. And this is what I'm trying to do today with you. We do provide this solution with our quite complete series of reciprocating compressors and screw compressors with a special focus, I would say, on compressors running with natural refrigerant such as the CO2, ammonia, and hydrocarbons. We do face today some big challenges that I'm pretty sure you are aware of, which can be summarized in two words, which are emission reduction. They are as simple as ambitious because this target can be reached only through a combined approach of direct emissions and indirect emissions. The latest review of F-gas and the REACH and ROS regulation tell us that we need to reduce and to phase down the current HFC's refrigerant. And even though there's currently an open discussion whether the new refrigerant should be just natural or whether they can be as synthetic based as well, we all agree that the new refrigerant should have a CO2 equivalent emissions at the lowest level, which means below 150 GWP. The second approach is about eco-design and eco-labeling, which is something to do with the indirect emissions and therefore designing the proper system in order to increase its efficiency. And it's about selection and availability of the proper components. We could not anymore using the existing components for approaching this big challenge. Again, these two challenges, these two approaches must be combined together. And the parameters that we always need to keep in mind is the TEWI, total equivalent warming impact, which is combining through this formula, which I will leave you, which I will let for your reference, is combining the direct impact of refrigerant losses plus the indirect impact of energy consumption. I'm pretty proud today of sharing with you some examples of companies that have been following this approach, providing to the industry quite clever solutions. There are four examples I want to share with you. One is a Swedish company, Enrad. The other two ones are Italian companies, Euroclimat and Tion. And the last one is a Danish company called the Solid Energy. Well, about the first one is the brand new winner of a Heat Pump Award 2022 in the car industry sector. And this, with their project, they aim at making the glass factory Magnor, producing furniture, the most environmental friendly factory in the world. How do we reach this result? By using heat pumps and chillers with the propane for their process heating and cooling heating in the production line. Then they use recovery heating and cooling for the building heating and cooling demand. I believe this is a very clever solution because they use the technology to get the most out of the natural resources. And I believe this should be the approach to be followed in our industry. The second case is about Euroclimate and is dealing directly with us because I share with you if the presentation will assist me. Okay, it's about reversible heat pump that we have installed in our brand new 800 square meters canteen. This heat pump has been chosen instead of heating boilers for winter demand and AC system for summer cooling demand. The heat pump is about 112 kilowatt, again reversible, meaning providing heating in winter and cooling in summer. And of course, when it comes to hydrocarbons, safety should come first. And we address this request with Altex certified compressors, meaning we in Frascold make a self-assessment on safety risk. We provide already Altex certified compressors to the industry. The third company I want to mention today is an Italian company which could not be considered anymore a startup company, even though they started their operation 5 years ago. This company is currently dealing and pretty busy in replacing the gas boiler in Milan downtown with a very clever heat pump in a range from 12 kilowatt up to 1.3 and 1.5 megawatt in heating. The configuration is pretty new because it uses a cascade configuration where there's a lower loop with propane and an upper loop with isobutane, which is able to provide temperature water at 80 degrees. Of course, when it's dealing with the residential application, compactness should be considered because this machine should replace the boiler in the machine room on the basement of the building and must have a noise level below 45 dB, which is the acceptable threshold in residential building. Then, of course, dealing with the residential, which is our electricity bill, the system must be as efficient as well. And Tion has shared with us their field measurement, which tells that they are able with this solution to save up to 58 on heating cost. They have shared with us the coefficient of performance trends in the all temperature range from 35 outlet temperature for the water up to 80 degrees. Overall, the efficiency result is a remarkable one because when the water is provided at 80 degrees, with an ambient temperature with a ground temperature of 15 degrees, the overall COP is 3.4. I let as the last, but I believe is the most important, results in terms of direct emission, because with this heat pump, they are able to reduce at zero the direct emission locally. And this is of primarily importance when it comes to residential area. The air quality has therefore improved thanks to no local concentration of nitrogen monoxide and dioxide, and no sulfur dioxide. Then the last example it's worth to mention today is about company Solid Energy, which is a Danish company providing heating district in all over Denmark. I shared in this presentation two examples which are similar in technologies and just changes in size. Therefore, I will describe the first one, leaving the second one for your reading afterwards. Therefore, in Galten, there's a heating district founded in 1964 that today supplies heat to more than 2,000 households. Originally, in this heating district, the heat came from wood chips, heat pumps, and gas boiler, with an heating production of 45,000 megawatt hours annually. In 2019, Galten installed a 3.5 megawatt air-to-water heat pump using 6 screw compressors on the biggest size. Well, based on the field measurement and result, in 2021, Galten decided to purchase and install an additional 7 megawatt air-to-water heat pump in order to fulfill the remaining heating demand. Supplying water at 70 degrees with a return temperature of 38 degrees. The average temperature in Denmark is 88 degrees, and with this average temperature, they are able to reach seasonally a COP of 3.11, which is again a remarkable result. I will let for your reading some economic consideration which will explain the payback of this project, but again, the results achieved in terms of payback convinced the municipality to add an additional heat pump in order to fulfill almost the heating demand. Let me then skip the Lokstrup district heating case because I want to come to the conclusion, which are simple because the message I want to forward to you is quite powerful. The decarbonization of heating is a viable option today using the HVAC technology and expertise with natural refrigerants, which make the decarbonization target even easier. Among natural refrigerant, hydrocarbons such as propane and isobutane are green gases with zero GWP, almost zero GWP, providing high efficiency and above all, the temperature level useful for residential, commercial and industrial purposes. Also, it's worth to share that heat pumps on medium and bigger size are not on a prototype stage, as I heard talking with some companies, but are already used in several applications from residential to industrial range size. Therefore, I believe we are in front of a pretty nice business case, and I believe as industry, we should address all our efforts towards this direction. Thank you very much.
Thank you very much, Livio, for your presentation. I don't see for the moment any questions in the chat. However, we have to move on to the presentations. So if you have any questions for Livio, as I said in the beginning, I suggest you that you write his name and then a question on the chat, and then we will see how we can give an answer to your doubts. So now it's time we move on to the, let's say, first project presentation per se. So the first speaker of the Heat Pump Award 2021 is Adam Armour Florence. Adam is the climate change officer for, I hope I pronounced it correctly, West Dunbartonshire Council. His background is in energy management, carbon management, and wider climate change adaptation and sustainability initiatives, largely within the public sector. So Adam, whenever you want, you can take control of the screen and start your presentation. You're muted.
Oh, you think after years of COVID that we'd get used to this by now. Thanks again, Irene, and thanks everyone, and it's a pleasure to be asked to come along and present on our Queen's Quay District Heating Network in Clydebank in Scotland. And I just wanted to make you aware that we're quite not as technical as Livio's presentation here, so we apologise to all you engineers who are possibly logged in at this moment in time. But I just wanted to say that, so as Irene said, that my background's in climate change and largely in the public sector. And the main thing for us within this project is to not just decarbonise heat, but also to future-proof the council and being able to deliver on not just decarbonising heat, but also improving energy efficiency of existing buildings and ensuring that new builds, both non-domestic and domestic, are of a high energy efficiency that would enable us to deliver on the net zero targets set by ourselves and Scottish Government. Okay, and let's see if this clicks to the next one. Excellent. Right, so just to give you a bit of a background of Western Bartonshire as a whole. So we're actually quite a small Scottish local authority based on the west of Glasgow and the west coast of Scotland. We've also got on the west the beautiful Loch Lomond in the Trossachs National Park. I'm sure many of you who visited Scotland have probably been there and agree with me on that it's a beautiful place. We're often considered what many say, I believe, the gateway to the Scottish Highlands. So many tourists who are coming from Edinburgh and Glasgow would come through our local authority area and to get to Loch Lomond, and that's the city of Ballach and Ballon. By city, I mean village, I apologise. So we have a small population, believe it or not. We have only about 89,000 people and a small area of about 68 square miles. But whilst we're small in terms of population and land coverage, we like to say that it's quite diverse in its land uses, in its natural and built resources, and a mix of dense urban form, rugged moorland, and spectacular watercourses. Now, we also have triple SI areas, so that's sites of special scientific interest, and national park area, obviously, in Loch Lomond as well. And where Queen's Quay is actually based is, if you can see at the bottom the bottom part of Clydebank, that's where we have located the Queen's Quay District Heating Network. And as you can see, since it's a water source heat pump, a large-scale water source heat pump, you'll see that the River Clyde is running around the south and running around the whole length of Western Bartonshire. So this, just to make you aware that we're already looking at other opportunities to see where we can harness the River Clyde itself to look for decarbonised heat going on in the future. Now, the important thing to realise for us as a council is that we've set a net zero target for 2045. Now, that was in response to the global climate emergency, of course, and we thought that it was really important that we, as a local authority, ensured that we had some form of preliminary actions and objectives to try and meet the challenges of being net zero by 2045. Now, that's kind of encompassed in these two documents that I've got here, which is the Climate Change Strategy and Action Plan. And of course, the Queen's Quay District Heating Network is a significant part of how we want to address not just decarbonising heat and our net zero ambitions, but also addressing the likes of fuel poverty. So by that, I mean reducing bills for our residents, because many of the people in Western Bartonshire we have are in fuel poverty or in poverty. So we have people who especially now in the current global energy crisis are selecting between paying for food or paying for their energy bills. So we as a local authority who are not allowed to make a profit based on any initiatives that we do are looking for the most competitive and cheapest energy tariffs for heating that we can provide our residents. Obviously in Clydebank, and then hopefully as we extend the Queen's Quay District Heating Network beyond Clydebank and beyond. Now, what that 2045 net zero target means is that we have some interim targets as a meantime to ensure that we're on track, because as you know, 2045 seems a long way, which it probably isn't, but we have many people in the local authority who can't accept or even digest the fact that 2045 is a long way away. So what do we do within that time? So we've set ourselves interim targets of 61% by 2030 and 87% reduction of 2040 as well. Now, that includes the operational emissions from our West and Bartonshire Council operations, but also the area as a whole, so the local authority area within Scotland. Now, just to kind of give you a starter for 10 of what we planned or what we wanted when we invested in putting this large-scale water source heat pump heat network in Clydebank. So our initial main aim was to lower bills for residents, offering a reduced tariff or a much more competitive tariff compared to the big energy companies that we have in UK and Europe, and also having no costs for our residents and or servicing and repairs. So what we mean by that is that when they connect to that, this council absorbs the cost of that through the use of the heat network, both in making the money from that through the likes of the renewable heat incentive, which I'll tell you about more in a moment, but also just the economics of the way it works itself. Second is obviously reducing carbon emissions and decarbonising heat. That's a big aim for us as a council, and we like to hope that addressing climate change will also help address inequalities when it comes to the likes of fuel poverty. And then finally is increased security of supply for our residents and non-domestic connections, ensuring a minimum downtime and constant access of heat. For us, it's something that we're still learning, but it's to ensure that the heat network is running to full capacity as best as we can and that there's no downtime so people aren't suffering as a result of that. Next. Now, so just to give you a bit of further background of Queen's Quay and the Clydebank area itself, so apologies if this bores you, but this is a nice little history lesson. So Clydebank was in fact bombed during World War II because we had a major shipyard called the John Brown Shipyard set on the exact site of where Queen's Quay heat network is placed nowadays. Now, so during that time, it's built some significantly important parts of naval ships for the World War II effort. But unfortunately, during that time, that was targeted during World War II and was bombed quite extensively. Now, just to give you a bit of an indication of what that actually is, Clydebank is made up of quite a varied range of different building types because largely due to the World War II bombing. Much of these building types were also temporary style buildings that were only meant to be up for 10 years. And believe it or not, some are still built at this time, right now in 2022. Now, also, it's probably important to note that then the shipyard was running and kept on going till the 1980s, until during the Conservative government, the Thatcher government at that time, closed down much of the industry. So Clydebank itself is a post-industrial town that has actually, even until this day, still suffering as a result of low employment and lack of job opportunities. And this we thought would be a really good example of trying to help address that by reusing a site that's not been used for years. People haven't been able to access it. And it's also, believe it or not, across the water from that is a triple SI. So it's a beautiful countryside just across the water with some lovely views. So we thought, why not try and redevelop and help regenerate Clydebank by doing a large-scale water source district heating network, alongside other things and engagement with the local businesses. Now, the district heating scheme has been broken into some basic phases, so I'll break them a bit more down in a later slide, but it's important to note that just the core scheme is properties on the immediate Queen's Quay site, so where the John Brown shipyard was, and then the extended key scheme is the connection of existing buildings on neighbouring sites and also new buildings going further afield across the whole town of Clydebank. Now, this was completed and switched on in December 2020, and is, as I've said, is considered Scotland's largest water source heat pump installation to date, and we're quite proud of that. And that's also, we as a council established a wholly public owned energy company called West and Bartonshire Energy LLP. And we, so as a council, have this ESCO, or Energy Services Company, that oversees the strategic development of the district heating network itself. Now, as a local authority who has never done this before, we then also included a long-term contract with a network operator called Vital Energy, and they're helping us with the actual connections and actually ensuring that existing buildings that we do connect are up to standard and have the relevant proper pipework and radiators in those buildings to ensure that they can actually be retrofitted to the heat network itself. Also, just to note that Scottish Government gave us funding for this, so they give us about 6.1 million in funding through the now defunct, unfortunately, Low Carbon Infrastructure Transition Programme. But we're also currently looking at opportunities with Scottish Government at this new form of funding, which is called the Heat Network Fund, which is about 300 million over the next few years that they're hoping to put towards heat network projects. Now, it's important to note that this kind of straddles Scottish Government's strategy with regards to local heat and energy efficiency strategies. So that's essentially setting all local authorities, all 32 local authorities in Scotland, have to, by the end of next year, have a local heat and energy efficiency strategy for their whole area and a development plan. Time will tell on that one and whether or not the quality of them will be good enough and that we'll be able to deliver these in enough time by that point. And it's also important just to note that alongside the funding that we got from Scottish Government, we obviously just in time managed to harness the renewable heat incentive, which is provided through Ofgem as part of the UK government. Now, that was stopped a few months after we got in. So we were lucky enough to get into this because we always say that for local authorities to give us as most competitive tariffs that we can for our residents, something like the renewable heat incentive is very important for us to ensure that we make sure that it runs efficiently and ensures that we're able to keep that afloat economically as well. Now, just to kind of give you an idea of what the energy centre looks like, so I'll just click onto that now. So this is the actual energy centre itself. So that's us facing the front. Behind us is the actual river itself. And you'll see the SSSI is also behind that as well. And Clydebank, you can see in the background, is what we're planning to extend out to in the future, now and in the future. And then also in here is what you can see is our two heat pumps that we use. So this was constructed locally by a local company called Star Refrigeration, based in a lovely village called Thornley Bank, if any of you can be able to understand that name. But essentially, this company here has been able to give us two heat pumps within the heat network itself at this moment in time to ensure that we are getting the renewable heat and the ensuring that the current connections that we have and future connections are able to give renewable heat to a certain point. Now, what does this look like? So I've just given a little diagram here just to kind of give you an understanding of what this is. So those heat pumps by Star Refrigeration, there are two 2.65 megawatt water source heat pumps. And we also have two backup gas boilers at 7 megawatt each, just to give us a resilience and to ensure that we meet a peak demand of about 20 megawatts with the current system that we have in the energy centre. Now, it can achieve temperatures of up to 80% if required. And within the energy centre itself, we have a capacity for either two new heat pumps or two gas boilers in the future. Now, the other thing for us is obviously we're still using fossil fuels as backup. Now, we want to be able to ensure that we're either using biofuels or maybe looking at hydrogen. We all have opinions on what hydrogen will play with heating homes, but even though there might be a potential that it could be retrofitted to ensure that we're using more renewable sources within the backup boilers themselves. Now, the River Clyde, as you can see the heat pump water intake station, and just within that station is a series of like major filters that stops the likes of sediments and fish and animals coming into the actual water pipes themselves before it reaches the energy centre. And then at the right, you can see thermal storage. We have a 120,000 litre thermal store that we then heat up and then use that as backup as well throughout the night when the electricity is cheaper for us. Now, important to note that we're also got plans to install another one as heat demand increases and as we add more significant loads to the heat network itself. Okay. Now, just to, I'm sure many of you understand how a heat network works, but this is just how it looks in a simple form with regards to us for the water source heat pump itself. So you see the River Clyde on the left. We extract water from that through underground plant in the room pumps and filtration system. Then it goes to the actual energy centre itself. and then it extends out to the existing Queen's Quay heat network and then beyond as we add more connections. Now, we have many phases that we've planned for this, so it's a long-term thing, obviously, for the local authority. But phase one, we've already, what we deemed as phase one is already complete. So that's 4 of our own buildings for the council. This was really good because it allowed us time to test and sort out teething issues and understand how we bill ourselves and how we bill the likes of providing more competitive tariffs for ourselves as well. Phase 2 is currently underway and almost complete. So we've just connected 145 social and affordable housing units. So this is homes for so affordable housing for people who want low cost housing, but also the likes of housing associations. So it's for people who are on lower incomes or on benefits. We'll be able to provide them with a really modern and warm home to actually use, and more importantly, a more competitive tariff, particularly during this energy crisis that we're in. We've just connected our 2 historical properties from 1919. So we have the Clydebank Town Hall in Bath and Clydebank Central Library. And right now we're just currently upgrading the internal fabric to ensure that it's not too cold for the people who work there, obviously, being historic buildings. And then we're in the midst of connecting the National Health Service Clydebank Health Centre. So that's due for the end of the year. Now, phase 3 for us is the major significant loads going forward for us. So West College Scotland is a big one for us, and then we're also in talks and on making good progress with connecting to the Golden Jubilee National Hospital, which is just along the road from the heat network. Now, just to give an example, that in itself is about 6 to 7 megawatt demand. So this is going to be a big thing for us as a local authority to ensure that the heat network is actually being used 24 hours, because right now it's not being used all the time because we don't have enough heat demand on the actual system. And then we also want to then extend from the hospital up to 9 high-rise blocks. So that's about 785 dwellings, that many of which are currently on electric heating and are paying, before the energy crisis, some were paying up to 32 pence for electricity per kilowatt. And that is a lot. So if we're able to connect them, we're able to offer them a more competitive tariff that will hopefully assist them in alleviating fuel poverty. Now, what is that tariff that we're currently offering? So for our domestic residents, we're already making a saving, because the current UK domestic energy gas price is looking at 10p per kilowatt hour with a daily standing charge of 28 pence. Now, that obviously will increase after April next year, because I assume they've removed the support that they were going to be getting from the price cap. But the current tariff that we're offering our residents who are currently connected is at 8.25 pence per kilowatt for heat with no standing charge. Now, that standing charge is absorbed into the tariff that we've providing them, and this is included within, because as a council we don't need or don't want to be making a profit, we need to ensure that we're at least balancing things out and offering as more competitive tariff for our residents as possible. Now, also alongside that, as I said, climate change and decarbonisation is also a major important thing for us. So the system itself, for every megawatt of electricity used, we have 3 megawatt of heat generated. So there's a 300% efficiency with that. We have a contribution towards reducing carbon emissions from connected sites by 15% over the next 7 years. And initially 409 tons of CO2 will be saved annually. So based on my calculations, it looks like almost we've achieved that. And then raising to 5,705 tons of completion. So that's obviously when we hit the peak 20 megawatt demand. That's what we'll be saving in carbon emissions each year. Now, what's important to note that this supports Scotland's Climate Change Emission Reductions Targets Act 2019, which obviously set the Net Zero 2045 target for Scotland. And this also delivers on requirements by the new Heat Network Scotland Act 2021. But also, to achieve this, the decarbonisation of heating and energy in the domestic and non-domestic building sectors will be key to achieving net zero. So the challenges for us, for a local authority, is to ensure private housing developers and that the relevant planning and building regulations meet the demands to ensure that we can actually install heat networks and the use of district heating into homes. Because, as you know, if the building isn't up to a high energy efficiency standard with regards to fabric, then there's a waste in heat, and then it's harder for the resident to ensure that they're getting warmer and that they're comfortable in their homes. And also it helps supports the delivery of, as I said before, local heat and energy efficiency strategies and delivery plan, which will be mandatory by the end of next year. Okay. Now, just to kind of give you, I love the formatting here. Just to kind of give you a basic comparison of the cumulative savings that we've made. The red line in there at the top just assumes that if our current heat load and buildings were sourced by gas heating, that's the amount of emissions that we'd have. And then the green line there is currently what the avoided emissions and the reduced emissions that we've had from connecting to a water source heat pump heat network. Now, it's important to note that that emissions are obviously influenced by the use of gas boilers as backup as well, and also because the electricity grid in Scotland is not fully decarbonised yet. So we can't claim that it's net zero until the actual grid is 100% 24 hours being sourced by renewable energy. And just to kind of talk about a bit of the next steps, what we plan going forward. So I did mention the Golden Jubilee Hostel here, and apologies for the quite blurry map here, but this is just basically the immediate area around Queen's Quay within Clydebank. And you can see along the west, up the northwest, you see the Golden Jubilee Hostel, which we plan to connect to hopefully within the next few months or within the year, give or take. We need to kind of iron things out first. And then beyond that, you might see the little word Dalmuir. So that's where the high-rise flats are based, where we hope to ensure that people are brought out of fuel poverty when they're connected to the heat network. And then just to kind of go a bit more detail on what this looks like. Through the local heat and energy efficiency process, we managed to identify, so this says 6 here, but we actually have 9 high-rise flats, which we plan to offer district heating to, and offer a far more competitive tariff as well. So that's the plans going forward. A lot of work to do, a lot of things we've learned, but just want to say thank you, and hopefully, Irene, I haven't ran on for too long, but hopefully that will give you a good idea of where we're sitting as a local authority with regards to heat network.
Thank you, Adam. It's okay, as it was a very interesting presentation, and like as you mentioned at the beginning, not that technical, so very nice. But either way, it's time that we move on to the next presentation because it is what it is. So the next speaker of the day, it's Morten Deding. He's the director for heat pump applications at Johnson Controls and has over 20 years of industrial refrigeration experience. He has been in the consultant, product, and project manager roles in his career, and is now using that experience to influence the adoption of heat pumps supporting electrification and the decarbonization of the heating sector. Whenever you want, Morten, I think you can take control of the screen already, and you can just pass your slides. Just one thing, I know that you wanted to share a video. When you will share the video, you have to disconnect your microphone. So like this, we can hear it correctly. Just the little piece of advice. Okay. So the floor is yours.
Does it show up okay?
Yes.
So you see my screen. Thank you, and thank you for the introduction, Irene. My name is Morten, and I work for a company called Johnson Controls. And the project that I'm going to present today is a project we were a partner of. So Johnson Controls will not take the credit for the project, but actually honor the building owner and the engineers and the companies behind it. So, but anyway, Johnson Controls is working heavily in heat pumps, and I've had the pleasure over many years to be a part of that. We are more than 300 heat pumps and more than 500 megawatts under our belt with industrial heat pumps, and they come in sizes from a few hundred kilowatts like the one I present today, up to a double-digit megawatts. It's a prosperous future. We work all over Europe and are quite a lot of people employed. So that's the offset, and also one of the reasons we were participating in this project. The project in Norway is a building that is owned and built by a company called Intra. It is sitting in Trondheim. That's very close to the Northern Hemisphere. It's a beautiful city if you haven't visited it. It's sitting on the pier, or the kaia, so it's called in Norwegian, the pier of Trondheim. And the idea of the building that Intra had was to create a building that was producing more electricity than it actually consumes. It is, and that it by itself is an achievement, because predicting what is the need for the building and actually otherwise proving it is a bit of an achievement, and Johnson Controls have been a part of that. Three unique thing about the building, on top of the building being covered in solar panels, PV, as I will show you, is that it's created with a low temperature heating system. It is created with one single heating unit, and it's using natural refrigerants. And all these three components makes it actually moving over the top, being a net positive building. So the building here itself is producing from the solar panels around 500,000 kilowatt hours a year. Half of that is used for the building purpose, meaning electrical lighting, computers, coffee machines, whatever. The remaining 50% is available for heat. So the goal here for the company and for the engineers was actually creating a system where the heat could be generated with such a high CUP that it didn't use more than the remaining 50% of the production from the PV panels. And that has been proven over a couple of years to be reality. In fact, it produces 5% more than it consumes. So it's contributing to electrifying and charging the taxis of Trondheim. I will move to a small video. It's 2.5 minutes. I will close the phone and turn on the microphone afterwards.
Okay, I'm just I took control again. Let's see if now it works, because I believe it was not working. So just give me a second and let me know if it works. Morten, I think you can take control again of the screen.
Yeah, and thank you. I hope you enjoyed the video. To me, apart from the view from the building, it's an awesome achievement by Intra here, and really, as the managing director is stating, this is a lighthouse. And to me, it's a no-brainer. This is how all office buildings should look in the future. So just a few facts. It's 80,200 square meters. It's 8 stories high. It has approximate an energy generation of close to 500,000 kilowatts hours. It's built by Skanska, who actually purchased the heat pump from Johnson Controls. Yeah. And in the picture here to the right, you see the heat pump. So configuration, what actually makes the heat pump the game changer here, we had half of the electricity available. So in that respect, we put in a heat pump for a central heating system, taking the energy out of the seawater. We selected a machine that was only one machine and was capable of doing the coincide 5 to 2 degrees and lifting from 40 to 50. And behind those numbers actually lies a couple of parameters that are important to know. One thing again, the 3 parameters are the low temperature heating system. It is the 1 unit only selection and the natural refrigerant. By selecting a low temperature system, you achieve the better COP on the heat pump. And what many people do not always consider is actually also considerably lower cost on the heat pump, and I will show you that in a later slide. You had to have some cost because a low temperature system will demand also a larger surface on your heating system, meaning in the heating surfaces on radiators and coils in ventilation systems. And then also add some cost to the building of thermal storage, meaning that you use the structure of the building to accumulate and equalize temperature changes, positive and negative. And then one thing, a low temperature system actually has the same pipe dimensions because it's carrying the same number of kilowatts hours. 1 unit is of course a troublesome on redundancy if it fails, but here there's a backup system. But the positive things about having only 1 unit is you achieve a better part load efficiency, and that can sound strange, but I will cover that topic as well. Lower cost for installation, you only have 1 set of pipes, 1 set of electrical cables, and you have also a significantly lower complexity in your system. And then last, natural refrigerants. At Johnson Controls, we can sell you anything you like in terms of heat pumps, low GWP, HFOs, or ammonia, or hydrocarbons. We have them all. In this case, we actually chose the natural refrigerant. We chose a unit that had a very, very low charge, delivering close to 300 kilowatts on only 15 kilos of ammonia. And that gives us a high efficiency due to the properties of the refrigerant. Of course, it requires a special room and it requires ventilation and sniffers to install an ammonia heat pump. But that being said, with a charge of 15 kilo, it's not a big task to do that. So the application here is delivering a COP or an efficiency of 4.3. When it moves upwards in temperature, meaning the harbor gets warmer, like 5 degrees, it actually achieves a COP increase of 14%. We have calculated it's calculated with a lift of 10 degrees from 40 to 50. But in cases where you could utilize a higher or get a higher pinch, or you could design your system with a higher pinch than 10 degrees going up to 20, there's also a CO improvement. And then the last thing is, had we, instead of choosing by the design engineers, chosen 60 to 50 instead of 50, 40 in this case, the COP would actually have dropped 20%, and meaning we would have not achieved the surplus energy production of the building. Another thing also, had we chosen 60 instead of 50 in inlet temperature, we would have reduced the capacity of the machine by 10%, meaning customer had to buy a more expensive machine. And lastly, every compressor is associated with a lift, and when you move up or higher lift, then you also have greater demands for your compressor. And in this case, it actually meant that we would have gone up in a compressor that would have required another set of bearings, meaning it would have gone up in what we call a 40 bar machine instead of a 28. So with this illustration, simply, we, together with the consultants, described a heat pump that was a low temperature heat pump, actually using existing refrigeration technology that we use on a daily basis in food and beverage. Had we gone higher in temperature and lift, we had moved into high pressure equipment with a 30 to 50% price increase on equipment and lower COP. So lift is associated with lower capacity and lower efficiency, meaning you are hit twice on your capex. So just to a rule of thumb, every time you change your heat source, every time you increase your heat sink, it has an influence on your capacity and your performance, and that was actually the game changer in this product, in this project. Looking at a heat pump, in case of capacity control, I have made a small curve here, and the black line here is the COP of a reciprocating compressor that is speed controlled. And you see that the curve is actually increasing in COP as you go down in capacity. And that's the fact with the reciprocating compressor, that the performance increases because the delta pressure, the losses in pipes and valves go down as you lower the RPMs. The pipes get, it's like the differential pressure in a pipe, it gets bigger. The pipe gets bigger as you lower the mass flow. Eventually, there's also mechanical losses in the compressor, and that means at around 50%, it actually drops in COP again. Second thing is that a heat pump or a compressor also has a change in adiabatic efficiency. And lastly, when you put this all together and as you lower the capacity on a machine, actually you increase the size of your heat exchanger, means that over time, or over the capacity range, in this case from 500 to 1800, there is actually an increasing COP due to the fact of overcapacity on heat exchangers and lower delta pressures in the compressor. That gives an increasing COP as you move towards the lowest capacity. and that was also a thing that was achieved in this project. So I think I have used all my time, or maybe more. Thank you, Irene. And if there's any questions, I will be available afterwards, or my contact details is in the presentation. Thanks so much for being able to share this today.
Thank you very much, Morten. So if you have any questions, use the chat, or as he said, his contact details will be available because we will share the presentations. So yeah, thank you very much again. And now it's time that we move on to the next presentation. So Petri Vuori is the CEO and one of the founders of the company Kalefa, founded with other 4 members back in 2013. Petri is an engineer in fields of techniques and has extensive experience in technology and industrial management roles. Petri is also a board member of the Finnish Refrigeration Enterprises Association. Green values motivate Petri everyday life, and he's a passionate hiker and a fly fisher. So Petri, whenever you want, the floor is yours.
Thank you, Irene. Introduction. And hello to all participants. So I will first tell you briefly about Kalefa, and then I introduce the industry winner case, Orion. Yes, here. So Kalefa is a Finnish company which is founded in 2015, and our revenue will be in about 10 million euros. We are innovative turnkey solution provider for industrial waste heat and ambient energy utilization. Our goal is to provide our customers easy turnkey, so a short payback time, which is usually like 3 to 5 years. We take care of identifying potential opportunities for waste heat utilization, system and equipment engineering, project management, procurement, relations, commissioning, training, and after sales. So we are building total systems for our customers. One of our services, our products are modular heat pump plants we call AmbiHeat. It can produce energy for district heating networks and industrial needs from local energy sources without CO2. We have our own production plant here in Finland, where we use different kind of heat recovery technologies in our systems, and we are manufacturing our own hot-level heat pumps and AmbiHeat heat pump plants. In our customers are or consist on energy companies and manufacturing large property. And the benefits for our customers always from energy savings and reduction of purchased energy. In many manufacturing industry cases, our customers get in addition more efficient production because we can increase the cooling heating capacity for processes with heat pump systems. And when our customers get energy savings and more efficient production, always means profitability to our customers. And in addition, they become more energy self environmental friendly when CO2 emissions are. Then case Orion, zero emission heating and cooling for Orion factory. Orion Ltd is a pharmaceutical company in Finland. This project started in a typical way for us. Orion's energy efficiency manager asked us help to improve the energy use and to reduce their emissions. As you see in picture, Orion has quite large factory area in Finland. It's about 4 hectares of real estate. They have industrial processes that requires cooling. Cooling is especially needed for air conditioning, so that the process conditions. And the cooling was earlier produced by chillers, waste heat needed the outside air, and at the same time they heated properties with purchased energy, which was district heat. When we became familiar with the energy consumption and energy trends, we gave our proposal where cooling for processes and heating for buildings is mainly produced by modular heat pump plant, Ampiheat heat pump plant, and energy consumption trends also relieved that process cooling is mainly needed during late spring and summertime and early autumn time. So in winter time, cooling is not much needed, and no waste heat from the process is available. So for this reason, another heat source was included in this heat pump system, which is the energy outdoor air. So this heat pump system uses both heat sources as a hybrid system and produce thermal energy for district Orion's own heating network. Here is some picture from our factory showing how the Ampiheat heat engineered and manufactured in Finland. After the manufacturing, the plants are delivered to the site as a module units by truck, and then lifted into the place by a crane. In this case, first module has 3 large heat pumps, and the second module has all the other infrastructure related to this pump system. And when the module parts are connected to each other, you get functioning heat pump. And the finished heat pump plant will then look like this. And the Ampiheat heat pump plant produces CO2-free cooling energy for process needs and heating energy for these Ampiheat heat pump plants are unmanned plants, and these are monitored remotely. So monitoring, controlling station can be performed. Then some project details. So this modular heat pump plant utilizes waste heat from the production process Orion, and second heat source is energy from outdoor air. You can use from -15 degrees to +30 degrees, and we can produce zero emission heat up to 90 degrees network of own factor. So this whole system is designed and is for a heat pump plant as a Orion heat pump capacity about 1.5 megawatt heating and 1 megawatt of cooling. Energy savings, reduction of purchased district heat up to 70%. District heating is still used as a backup heat coldest weather of winter when higher heating capacity is in factory's own heating net. CO2 reduction this system about 1,000 tons per year. And of course, Orion get secured cooling capacity. New heat pump plant will take care of process cooling, and the old chillers remain as a backup system. Thanks everyone.
Thank you, Petri, for your presentation. It's time that we move on to the last presentation of the day, and that is by Andy Johnson. So Andy, he brings change into operations. He's led by a desire to find new and positive ways to answer today's challenges, identifying new ways for supply chain and factories to be different and better, and to demonstrate how they can be more sustainable for the planet and people who work there. He joined Innocent Drinks back in 2019 to build the Earth's favorite little healthy drinks factory in Rotterdam, the Blender, and that's what he's on here today to talk about. So Andy, whenever you want, the floor is yours.
Yeah, I'm there. Can you hear me?
Yes, we can.
Okay. So pleasure to be here, and thanks for inviting us and organising us, Irene, to talk to the audience today. My name's Andy, and I want to tell you something about our factory, which won the People's Choice Award. And as Irene said, we call it the Earth's favourite little healthy drinks factory, and its name, we gave it a name, it's called the Blender. And the reason I want to talk about our one factory is because, unless anybody else didn't notice, we are in the middle of a climate crisis, and our one factory is just that. It's only one. But if we can share some of the things that we've learned and what we did, and if that can inspire wider change, then one factory can multiply its effect as far as climate change is concerned, and hopefully have a many times effect in that regard. So that's the reason. And what we do is we, as a business in our industry, we open source to any of our peer companies what we've done, and that would include our competitors as well, because we want them to get on with the transition as fast as possible. So we don't see this sort of process information. Our product information is very precious to us, but how do we decarbonize is not precious to us. It's a little bit like safety. We want to just share it and make sure that people get on with it as fast as they can, basically. It's too important not to. So that's why. And then what I wanted to do next was just give you a little bit of a sense of who we are, very briefly. Innocent Drinks, it's a very big juice and smoothie business, as probably most of you know. These three guys, John, Rich and Adam, were the founders of the business. They started with this aim in mind, which was to make natural, delicious drinks, food and drinks that are going to help people and the planet live well and to die old. And that tells you something about the culture of the business, really. It's a business that started by these three guys trying to do something positive in the world. They didn't quite know whether they could get a business off the ground, but they started making these nice smoothies at one stage and went to a music festival and sold their drinks at the festival. They had 2 dustbins there. one had yes written on it and the other one had no, and they had a little sign over their stall saying, should we give up our day jobs and should we make these things for a living? And at the end of the festival, the bin that said yes was absolutely overflowing with cups, and that's how the business started. And the thinking of these three guys carried through into the business that is Innocent today, and that was 24 years ago when these guys excuse me, I'm trying to move my slides here. 24 years ago when they started that business. Those guys are now not heavily involved in the business. We've got a new CEO, but we continue to carry that theme and those ideas through everything that we do as a business. And our ambition as a business is to be this thing we call good all round. And what that means for us is it's bringing three things together: what we do for people, our own employees and the community around us, what we do for the planet, and then how do we bring those two things in balance with becoming a profitable business. And if we get those three things in balance, that's what we mean by being good all round. And we think we can do that. And that ambition is also reflected in our membership of and contribution to the B Corp certification process, which is all about businesses that do balance those three things. And we also are a leading sponsor and influencer, if you like, in terms of the Better Business Act campaign in the UK, which is again all about asking businesses to enshrine those three things in their articles of association, so that we're not just considering the shareholder, but we're considering stakeholders like employees, the community and the planet in the actions of the board of the business. So that's a little bit about us. And in terms of how we want to help the planet, we've got an ambition that we get to carbon neutrality by 2030. And the bit I'm going to talk about today is the blender, and that's pretty much a keystone in our plan to get to that point. And here it is. It's Innocent's very first own factory. We previously worked through a network of bottler partners across Europe to make our drinks. And this factory now live, you see it here on the western seaboard of the Netherlands, partway through construction in this picture, will and is on its pathway to doing this, bottle about 70% of all of Innocent's drinks supplied across UK, and that includes the UK, Europe and the UK, sorry. And it's designed to be operationally carbon neutral. And here you can see it partway through, as I said. It's out on the west side of the port, and I kid you not, it's got the best view of any factory you can imagine to work from, looking out west to sea with these big container ships coming by. So nice place to work. So just moving on to our ambitions for the factory. Just like the company, we've got an idea of what we want to be, and it's really summarized in three things, just like for the company. So the Earth's favorite little drinks factory wants to be a factory for people, and we emphasize the word for when we say that. So it's not, we don't want to bring people in to be part of the factory, but we want to create a factory that's actually a great place to work for people. We want to be the planet's friend, and we also want to help our business become a better business in doing those three things. And today we're going to focus our time on the planet friendly side of things, but we could talk a lot about the other aspects as well at another time, probably. Whilst we're going to talk specifically about managing energy in this area of planet friendly, we've also done some interesting things which, you know, again, could be a future conversation, but we're the first site in Europe to be operating 50-ton gross vehicle weight battery electric trucks on a regular basis. So that's something we're very, very proud of. We've also, in the design of the factory, incorporated new technology that allows us to clean and manage the water for the factory down to minimized levels. So we use actually air, very high velocity air, to clean our pipes in the factory before ever introducing water to do the last cleaning processes, and that makes a massive difference in our water footprint as an operation as well. So the philosophy here in terms of creating building the factory was to use the opportunity as a step change in the company's journey to carbon neutrality, as I've said. And when the design thinking started back in 2018, we had lots of options on the table for our energy design, things like biomass, biogas, and other technologies. And interestingly, none of those things was looking particularly attractive to us. We didn't have a really a good feel about the solution that was on the table. And what I wanted to say today was one of the learning things, learning points for us as we went through the process of design was almost accidental, but it's one of the biggest learning points in the whole story, was that we put our process engineers, our process team, in the very same room as our heating and refrigeration specialists to review the options that we had with regard to the energy solution for the whole factory. And what happened was quite, well, I suppose it's quite magical in one sense, but it led to the basis of our design today. That's the important point. And it sounds obvious to say it, but it's actually what most of us in our industry don't do quite naturally, is to put those two parts of our, if you like, our design processes together as we work through the design. And we, I think, did this almost accidentally, but it led to what we've arrived at. So now what we've got is a design, which, when we compare it to other food and drinks factories, is quite special in that it is entirely electric. There is no gas supply. We had the opportunity to bring gas to the site within the lease that we have with the Port of Rotterdam. And at one, I suppose, nail-biting point in time, we took the decision to opt out of that being something we bought into, and we said, no, don't bring the gas out to the site. We've got a solution that's all electric, and we believe in it. And so that was quite a moment for us. And it's quite interesting in that I don't think I've worked in a factory in my kind of industry, food and drink, where there's not been a fossil fuel supply of some kind. So yeah, we've got something quite special, and we believe it is, and we're quite proud of that. And the purpose today is obviously to try and share some of that learning with the audience here today. And I did say that the design process was quite accidental. And what I've put on the slide in front of you on the right-hand side there is actually the sketch that went, this is the sketch from the wall of the meeting room where we had all of those engineers together. There must have been about 15 folks in the room together. And what was being eked out and eventually got drawn here that you can see on the right-hand side was the model of what our kind of factory looks like. Big refrigerator on the far right-hand side, which is our finished goods refrigeration high bay warehouse, refrigerated warehouse, and then all of the demands for heating and cooling that might supply that factory. And you can see top left, I was thinking about a boiler that might have been there, but we actually figured out that we didn't need it when we looked at some of the heat loads and heat demands and heat available to us, and how we could balance those things in the future. And I've credited the guy who actually sketched that out onto the wall, Rob Unsworth, who's from our Gaia partner, who actually provided a lot of the refrigeration technology, heat pumps, and overall design for us from an energy management point of view to the site. And what that design that you can see there translates to is essentially this chart in front of you now. So just to show you that the sketch is replicatable once you get down to the basics, and what you've got in front of you is what we've installed into the factory. Okay, so what I wanted to do next was really just talk about the stages of the evolution of that design, and so how it came about really. And the way I think of it is that we had to go through different phases and different cycles. And the way I'm going to talk it through is probably linear. Well, it is linear, but I don't think it really in reality was quite as linear as the way I'm going to describe it. It wasn't as perfect in practice, but the phases are distinct in my own mind. So we can plot that journey in 4 steps. And as I've said, it wasn't traditional. We put together the refrigeration technology guys together with our process guys and girls and ask them to think about their needs as a team rather than, as would traditionally be the case, put the process team together to map out their required services, and then those be provided by another team, and never get into the optimization of the process between those two groups. So, first phase for us was to think about and to look at the typical profile for a food processing facility. And here on the chart, you've got a series of temperature zones or requirements for heat and a series of requirements for cooling down the right-hand side. And the first stage was to challenge ourselves to consider whether we needed all of those. What were the requirements, and could those be modified such that we would start to think about how to tune and optimize the needs of the factory. So that would be things like decreasing the temperature levels for pasteurization, and that's what I mean about putting the process team together with the energy services side. Traditionally, we would say in our industry we want to pasteurize at about 90 degrees Celsius. And that's the requirement. Go give that to me. In the conversation, we got into the bones of that to say, actually, if only you could bring down the temperature you want to pasteurize at, pasteurize for longer, lower temperature, then we can deliver something to you in an optimized way. So it's conversations like that that were taking place, and you can see some examples on this chart about, you know, the way we would melt our frozen juices that arrive here, or changing the chill temperatures that we use, maximizing those, and just modifying them by a small quantity can have a big impact on the efficiency of the systems that we now run. So we're running the warehouse approximately 1 degree Celsius warmer than we might have done, as an example. And also, what we did do was to split out all of those energy needs at temperatures that were lower than steam temperatures to try and find the solution to delivering that service. And what that meant was the amount of steam that we really required to be generated on the site, and we do need some, was minimized. We have 2 electrical steam boilers, and everything else is serviced by the balance of the energy solution that we've got here. So that's really the first phase, was optimizing and pulling down the temperature profiles. And then we move into a phase of reuse, really. So how do we introduce more energy efficient processes to take existing and available heat sources and take them through and into other parts of the process? So preheating of water, or better pasteurizers or more efficient pasteurizers that could do the work that I just talked to you about, was the next phase of the design process, really, so that we got an essentially effective use of existing heat source moved to a different part of our factorial process, and doing useful, valuable work to us. And it's saying, again, it sounds obvious to say that, but without putting the teams together, we would be missing out on some of those opportunities for sure. No question about that. And then the third part of the process being, oops, I'm getting ahead of myself in terms of slides here, so bear with me a second. Yeah, the third part of the process would be, and is actually employing these kind of beasts that you see here. What these are pictures of our ammonia-based heat pump system going into the factory during the construction phase, and essentially they're doing the third piece of the process, I guess, of generating our energy solution, and that's this, which is upcycling the waste heat from our cooling systems. So we've got waste heat going to atmosphere at about 35C, and bringing that back into play by promoting it first to 65 degrees Celsius as a useful reservoir of heat for process needs and domestic water needs as well. and then taking that 65 Celsius water via a series of additional heat pumps up to 90 degrees Celsius, and that being our reservoir of heat essentially for things like pasteurizing, as I've said already. The heat pump systems are taking that energy and promoting it to those temperatures and storing it into 250,000 litre water silos that sit outside the factory. So we've got a huge energy reservoir at both of those two temperatures, which provides the inertia in terms of of heat, and also the reservoir to provide the services to the factory. And that's the core of how we've been moving, both reducing and then moving energy around our site, essentially. But, whoops, we still require power. Okay, so we've reduced, we've reused, we upcycled, and then there is obviously a residual amount of energy that's required on the site, and that's provided to the whole facility by two types of renewables. So we have solar panels. We've got something like 3.8 megawatts of generating, I think it's 3.8 megawatts of generating capacity of solar, and then we have two 4.25 megawatt wind turbines on site. The combination of those three sources gives us approximately 29 gigawatt hours of generation annualized, and we can see now that we're up and running, that's well in excess of what we need to run the site from an energy demand side of things. So we effectively create a factory that's a net exporter of power annually across our grid network, and that's how we get ourselves to become the CO2 neutral factory we want it to be. So yeah, I'm only recapping to say 4 cycles to this, and I think the most insightful learning for me was put the people that are representatives of different parts of the building design, the building and process design process all together to look at some of the opportunities at the start, and really got us into thinking really cleverly about moving this precious thing called heat around the opportunities that present themselves. Without doing that, we'd have been allowing that precious thing to be wasted when yeah, that's not what you need to do if you're going to get there. And there you go. That's all I wanted to say, really, was to give you a bit of a feel for the process that we've been through, and show you that it is actually possible to generate an operating unit like ours with a CO2 neutral ambition in mind. And we're living proof, and happy to share that with anybody that you on the call might feel is interested after you've heard me talk about it. Thank you.
Thank you very much, Andy, for your presentation. I have to say that I really love the visuals used personally from a communications perspective.
Thank you.
So I think it's time that we move on to, let's say, the Q&A session. We don't have much time, but I'm sure like we have for sure one question in the chat, and then I have some questions for you here as well. So let's do the most of the time we have, shall we? So on the chat, actually, it's a question that you asked Andy to Adam, that basically you're mentioning that what he showed was looking great. And you asked if he had mapped a pathway out for the rest of Western Bartonshire that he feels is accessible to district heating. Like, it's on the chat, like, but I think it would be nice to address it.
Sure. I can't get the chat up my end, unfortunately, so I can't see the questions. Sorry.
Adam, it was just to ask you. I mean, what you've got there is brilliant. I just wondered, with all the learnings you've got now, can you see your pathway out to the other areas of West Dunbartonshire that are obviously geographically further away from your project at this point? So do you see what those steps would look like at the moment, or is that is that to be done?
No, good question, Annie. So we've had So obviously, you know, there's only so much we can say about the talks with existing potential connections as well. But we do have Clydebank Housing Association. Whilst they're called that, they're a bit outside Clydebank, and there is potential for their current CHP systems that because they have their own localized CHP but they're pretty much defunct now. So it's came at a really good time that we're able to go out and connect to them. So in fact, immediately north, we're actually having talks with them to connect 7 other high-rise flats as well. And there's also along the main road as well. We've had some talks with Police Scotland as well, who have a couple of police stations along the border in Glasgow. So I think for us, going over the Western Bartonshire border into Glasgow is also an important thing for us, but that's a partnership approach we need to discuss more with Glasgow City Council as itself. The way it looks forward is as soon as we max out the 20 megawatt, so 20 to 21 megawatt, there is potential, and we've been talking with Scottish Water, who has heat from waste. So there is a actual by heat from waste, I mean human waste. So there's that further up the river as well that we can use as a boosting or, you know, a sort of smaller heat generating area. And also we're in talks with a local distillery to use their leftover heat as well to kind of boost that. So we're all in initial talks for the wider expansion of that area, but all of it's been positive. I think for us, as you know, Andy, it's multi-million pound extension of the network, and also lots and lots of groundworks that need to occur, particularly across the railway line and the canal as well. So that's the challenges that will face us going forward, is the physical challenges of doing that and ensuring the likes of Network Rail are on board with what we want to do.
Thank you.
Thank you, Adam. And now, Andy, do not disconnect the camera. There's a question for you in the chat that mentions what powers your plant when the wind is not blowing and the sun is not shining.
Yeah. Okay. Well, we balance with the grid. So essentially, we tie into a renewable contract from the grid, and the way we conceive of ourselves is over generating at certain points in the day of the week, the season of the year, and under generating. The net position is that we will overpower, so we'll export a small amount more than we're going to consume as an operating site, but we rely on the grid. You know, we don't have a solution that means we are completely off grid, so we need to be able to, you know, when the sun doesn't shine and there's no wind, we have to have power coming to us, but after that, then we're also exporting.
Okay, thank you, Andy. Okay, we're receiving more questions. That's good. So this is a question for all. The person is asking for thoughts on whether to use excess renewable electricity to store in battery or thermal storage. Not sure if you can answer the question now, but
I got a couple of points, which is we are exploring some of those ideas. On the excess thermal side of things, we're working and thinking and talking with some groups that are proposing, I wouldn't call it high temperature, but it's higher than we need. High temperature thermal stores maybe is the right phrase. So storing, using our excess renewable generation to heat up a thermal battery to sort of 500 degrees C, and then we can pull from that when we've got low generating capacity potentially. So that's something we're interested in, and I do think it's part of a future solution across the mix that we need is thermal storage.
And Adam, you have raised your hand, so
yeah. So our energy centre currently has thermal storage of 120,000 litres, and we're looking to add that as well as the demand increases on the energy centre itself. So that forms part of the current and future economic modelling that we're doing to ensure that it's as efficient and we're providing as green enough heat as possible.
And then Morten.
Yeah, just a comment, because Also for industrial heat pumps, we see a tendency that if there's an overproduction of electricity, that you actually get paid for reducing the taking away the excess generation. So here we try to ramp up the heat pump as fast as possible. So a combination of electrical boilers that start, and then later on you put in the heat pumps, and then thermal storage. That's a thing for district heating. Also using the grid extremity as a source of storage is also something looking at. So taking away excess electricity, storing it and using it for less for underproduction of renewable electricity is something you need to include in your overall thingy when you're doing a heat pump installation.
Thank you, Morten. And then I wanted to ask as well if Petri has some comments regarding this question. And if not, I have a question for him as well. So, Petri, you mentioned like this ambi-heat heat pump plants, but I wanted to ask you, what is the maximum temperature this heat pump plant can actually produce?
Well, in this Orion case, their heating network is designed for 3 degrees. With our
I think the answer was a bit cut. Like I didn't.
Okay, yeah. So in this case, Orion's own heating network is designed for 90 degrees, and we can reach that. But our heat pump technologies can produce temperatures up 120 degrees.
Okay, thank you very much. And then I have a question for you, Morten.
Yeah.
You presented an installation, so I wanted to ask you if this installation is unique and if it can be cascaded or replicated anywhere or elsewhere, and where would it be replicated if it could be replicated?
So of course it could be replicated everywhere, and thank you for the question. I think today we are looking at. I see customers in industrial refrigeration who have cold stores that put off PV panels on the roof of their cold stores. Some of them exceeding 20% of the electricity actually coming from using their own roof. The potential of using the surface of your building to generate electricity to drive a heat pump is something you can use anywhere. So sometimes you can cascade the idea, and if you have a building like Powerhouse Brattakoya, who is a modern building designed after the most ambitious codes and standards, you can achieve the net zero building. But for like all buildings, you can achieve some sort of neutrality, maybe 30, 40, 50%. So it's just a matter of putting on the PVs and then installing heat pumps. If you have excess heat or renewable heat available, it is cascadable to all installations. Invest in lowering the temperature of the application is also driving a business case. So it's not only putting on the PVs, but that was actually my message today. Also look at your heating application temperature. Driving that down will increase your business case on the heat pump.
Okay, thank you very much for your answer. Unfortunately, we are running out of time, so I want to thank you all for being here today and for your interesting presentations. We will provide all of you attendees and people that have registered to the event with the presentations of today, as well as the recording in the next days, so please be a bit patient. So I wanted to ask you all that if you like this event and you would like to learn more about what we do in HPA, or to follow us, there's like a QR code that you can scan, so you can have all our social media accounts, our website, subscribe to our newsletter. Then, of course, I want to ask you all to keep checking on the Heat Pump Awards, because of course these wonderful projects were here presented today because like a couple of years ago they participated in this award, which I personally I really appreciate. And of course every year we're searching to discover all these very innovative projects. So again, thank you all for being here, and I want to wish you a wonderful day.